Okay, let's begin with a question from your homework. It says, which of the following would require the greatest number of calories? Pause the video and make your choice. I'm just going to give you the answer now, and then we'll circle back in a few minutes to explain why the answer is A. Heating 100 grams of water from 10 degrees Celsius to 50 degrees Celsius. Obviously, the key here is heating, or because this is a lesson about heat, then we should define what it is. Let's begin with a textbook definition. Heat is the transfer of energy between a system and its environment due to a temperature difference between them. Let's highlight some key phrases. First one is heat is a transfer of energy. I think some people, or let's say everyone at some point, they might use the word temperature instead of heat and use them interchangeably, which is incorrect. Because let's say when we say the heat outside was unbearable, that's incorrect. What we mean is the temperature was really high. But that's okay. So we have to be more precise in our language and know that heat is a transfer of energy. Okay? Also, why does this happen? Well, there has to be a temperature difference between them. If there's no temperature difference, then there'll be no exchange of energy. Now, let me go a bit more in depth about how this is a transfer of energy. Let me give you an example. So let's say you have a box and then you move it. To move it, you do work on the box. Well, you don't say that by moving the box, you added work to it. You said because you did work, you change its energy. Likewise, let's say you want to make coffee and you boil water. You're not adding heat to the water. The water doesn't have more heat as it boils. It increased its temperature due to heat, due to that transfer of energy. All right. So let's talk about the units for heat. When this branch of physics, thermodynamics, was being developed, there was no apparent connection between mechanics and thermal physics. So the unit which was selected or defined was the calorie. Okay, calorie. Now let's see what the calorie is, or what it means. So calorie is the energy required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. I know that's a little strange. First of all, we needed a familiar substance, in this case water, and it is very specific that you're raising the temperature of 1 gram of water. And if you think about it, this means 1 degree Celsius. So that's a calorie. You might be trying to relate this to food, because when we eat food, we see we say we're eating calories. But those are actually different slightly. So a food calorie, I forgot to say that the abbreviation for calorie is CAL. Now this is intentional, lowercase, okay? So a food calorie, likewise I'm using capital C. Abbreviation for food calorie is capital C, AL. Let's say 1 food calorie, to be more precise. 1 food calorie is equal to 1,000 calories with lowercase c. All right? Just so you know. Now, when there was now a connection between thermal physics and mechanics, that is, when scientists saw that you could use heat, transfer of energy, to produce work, they needed to use the unit, or they needed some type of connection between the unit of energy we have used thus far, which is joule, and calorie. And of course, there is, and it has a very technical name. It's the mechanical equivalent of heat. And it says that 1 calorie, lowercase, is equal to 4.186 joules of energy. That's the conversion. That's how you can turn heat into mechanical energy using this conversion. Because for our purposes, although we can use calories, because this class is more about what happens dynamics and also mechanics, we're going to use joules more often than we'll use calories. Okay, now let's keep talking about heat. Let's go for this example. Consider the following statements. Heat flows from an object with higher thermal energy to one with lower thermal energy. Heat flows from an object in liquid state to an object in solid state. Heat flows from an object at higher temperature to an object at a lower temperature. Which statements are true? Pause the video, pick one or more answers. All right. Now let me give you an example that will illustrate the answer to this question. Let's say you have a glass. You have a glass of water, and then you have some ice cubes in it. Okay? And then some time passes, and now you just have water. The question is, how do you think the water will feel from here to here? So this is the moment right when we put the ice cubes in, and then this is when they melted away. I think most of us will say this will feel colder, and that is going to give us insight about how or the direction of heat flow. In this case, this happened first, this happened after. So then we can say that now let's say we have these two objects. This object is at 50 degrees Celsius. This other one is at 10 degrees Celsius. Well, we can say with a high level of certainty that the transfer of energy will be from the hotter object to the colder one. Okay? So the temperature of this one will increase and the temperature of this one will decrease because there was an exchange of energy between this object and this object. Although the reason behind it has to do with something called statistical mechanics, collisions, we can safely say that heat flows from hot to cold, which is to say that heat flows from objects with a higher temperature to objects with a lower temperature. So then we can safely eliminate B. Why? Think about it. Let's say you had liquid nitrogen, which is really cold. Then you get a hot piece of metal. The metal's solid, liquid nitrogen is liquid. Of course, the heat will flow from the hot metal to the liquid nitrogen, which contradicts this one. Now, A or C. So, the amount of thermal energy in an object not only depends on the temperature, but depends on the mass. So, for instance, let's say you had, again, a hot piece of metal, and then you were to throw it into the sea. Although the sea would have a lower temperature because of its mass, it has a higher amount of thermal energy. Nevertheless, we know that heat will flow will flow from the hot object to the sea, which means the only correct answer is C. Heat flows from an object with higher temperature to an object at a lower temperature. Okay, let's keep going. One of the major effects of heat transfer is temperature change. So heating increases temperature while cooling decreases it. Okay? And now what we're going to talk about is going to help us answer the bell ringer. Let's start with an example. Let's say you wanted to change the temperature of 1 gram of water by 1 degree Celsius. How much energy would you need? You would need 1 calorie, which is 4.186 joules. What if you wanted to if you wanted to change the temperature of 1 kilogram of water by 1 degree Celsius? Well, because a kilogram is 1,000 grams, you would need 1,000 calories, or a food calorie, which is 4,186 joules. What if you wanted to change the temperature of 1 kilogram of copper by 1 degree Celsius? Because copper is a metal, is a better heat conductor, we wouldn't need 4,000 joules. We would actually need 387 joules. What does that tell us? That different substances change the temperatures differently. So then we can say the relationship between the way in which different substances change their temperatures based on their composition and how much of that stuff you have. So this is the, I'm going to say, main equation for this lesson. All right, let's label this thing. All right, so this lowercase c means specific heat because it is specific for each material. Now, that is a relationship between the amount of heat transfer. So because it has to do with heat or energy transfer, this is going to be in joules or calories. The mass, we know mass is in kilograms. And temperature difference in this case will be in degrees Celsius, although we could use Kelvin as well. We're going to use degrees Celsius. That tells me that the units for specific heat, SI units, is going to be the joule over kilogram times degrees Celsius. Again, this is specific for different substances. So what do we do with this? Well, we want to know, we can use it in different ways. But ideally, we want to know the relationship between heat transfer, the energy we have going into or way of the system, and how that energy is changing, how that heat is changing temperature. So if we multiply by this product, by the product of the mass and temperature difference, we'll end up with this formula, which is the one which is in the form we'll use it the most. I'm going to box it. And you can see heat transfer depends on mass and change in temperature difference. So if you know the amount of energy being transferred, then you can predict how that temperature is going to change. Or if you know the temperature difference, then you can know how much energy went into the system or away from the system. My apologies. So we can call this the quantitative relationship between heat transfer and temperature difference. Let's use this and go back to the bell ringer to see why the answer was A. Let's write down the equation again. So we can know in this case the substance is water, meaning that the specific heat is the same. So the answer has to be just the product between the mass and the temperature difference. So the mass of this is 100. So I'm just going to use numbers, no units. Sorry if that offends you. Times temperature difference from 10 to 50 is 40. So that's 4,000. That'll be 4,000. This one is 1,000 grams. 1,000 times 10 to 12 is 2. That's 2,000. Then you can see the rest. This is 1 times 70. Next is 10 times 30. So then the one that has the bigger product is 4,000. So that is why A is the answer. Hopefully that made sense. So this example, I'm going to record a different video. This is very important for your lab. It's going to help you with the mathematics to finish your lab. See you on the next video.